Here's a more detailed analysis of aggregate formulas and examples of their use. First, let's review some concepts. Aggregate formulas allow you to perform calculations or searches involving many records in a table and related values from the extended table of the table run-through. These formulas allow us to count with count, sum with sum, or average with average several records, perform searches such as finding the maximum with max, or minimum with min, the value of an attribute in a set of records, or given many records in a table, find the value of an attribute using find, whose record is the first one found that meets certain conditions. In the syntax, the aggregate expression will be the one searched for, maximized, minimized, summed, or averaged among the records that meet the aggregation condition. It can contain attributes, including formula attributes, constants, and variables. User-created variables are only allowed in inline formulas. In global formulas, only variables that exist in the entire Unix object can be used, that is, system variables, such as the today variable, for example. Only for the count case, it's not an expression but an attribute. For sum and average, the result of the aggregation expression must be a numerical value. The aggregation condition is the condition that records must verify to be considered in the aggregation. It can contain attributes, constants, and variables. User variables only in inline formulas. It's optional and may not be included. The default value will be returned when no record is found on which to perform the aggregation. It may be because none meets the aggregation condition, because it doesn't meet the implicit aggregation condition, or because the table is empty. It's a constant and is also optional. The return value is the attribute whose value is returned by the formula when it finds records that meet the aggregation condition. While the return value may be a value, as in the case where the default value is returned, it's usually an attribute. Its inclusion is optional, and only some formulas carry this fourth parameter. The triggering condition is the one that determines that the formula is calculated with the aggregation expression that precedes it. It's optional, and the only attributes allowed are those belonging to the associated table and its extension. Triggering conditions can only be used in global aggregate formulas, because in inline formulas, they're not part of the formula definition, and their triggering is conditioned in the code by means of conditional clauses. For example, if, else, do case, and so on. While a horizontal formula needs a context to be evaluated, an aggregate formula does not necessarily need one. However, if a context table exists, not all the records that the formula explicitly states will be considered, but only those that also match the implicit conditions arising from that context. For example, the flight capacity attribute of the flight transaction is a count formula that runs through the flight seat table and counts the number of seats on the flight. Since the table associated with the attribute is the flight table, which has a one-to-n relationship with the flight seat table navigated by the count, only the related records will be counted. In other words, the seats corresponding to the flight instantiated in flight. If there were no relationship, all records in the flight seat table would be counted. In addition, as we indicate that only seats that are windows will be counted, only those that meet the filter condition will be counted from the set of related records. Since it's a count formula, the aggregate expression is only an attribute that determines the table where the records will be counted. In this case, flight seat location. The aggregate condition is the filter that the seats must meet, that they're window. Also, since it's not a max or min formula, it has no default value, no return value, and there is no trigger condition defined. Here we see the same definition as an inline formula in the source of a procedure. In this case, where the formula is loose, there is no implicit condition. the window seats of all flights will be counted, not of a particular flight, as was the case with the global formula, or as would be the case if placed inside this for each. Let's analyze a particular case, which is when the formula is in a certain context and the table navigated by the formula matches that context table. In this example, we want to print, for each invoice date, the sum total of all invoices with that invoice date. The table navigated by the sum formula is invoice, and it matches the base table of the for each, which is also invoice. In this case, due to the unique clause by invoice date, Genexus will group the information by invoice date, both in the for each and in the sum formula. That is, the sum formula will have an implicit equality condition by the invoice date attribute, which will be considered as given. It's as if it were a control break, breaking by invoice date. Let's see the navigation list. We check that the base table of the for each is invoice, and that the unique is by invoice date. Below, we see the formula that's also grouping by invoice date. Note the group by. And also, invoice date is given. Therefore, it will add only the records of that date, just as we wanted. What would happen if we removed the unique clause? If we don't place the unique, how does Genexus know that we want to add only the invoice totals of the invoice date on which it's positioned? That is to say, if instead of writing the formula, we decompose it in its calculation through a for each, what will be printed? We do have a control break, but we're not indicating the break criteria by invoice date. We have not specified an order clause for the external for each, so it'll choose a primary key, and it'll always stay in the internal for each with only one record, that of invoice ID. However, let's look at the navigation list displayed by Genexus. Note that the unique clause is no longer shown, but Genexus automatically adds a distinct clause, so the result remains the same. Genexus had the intelligence to detect that we wanted to group by invoice date, and reflected that in the code generation, making the list work the way we wanted. Although Genexus, depending on the case, is capable of automatically detecting what the developer wants to do, we should include the unique clause so that our intention is clear in the programming of the code. Now let's see a similar case where a table is navigated and an aggregation is performed on the same table. In this case, the aggregation will be a max formula. Let's suppose that given a customer who has many trips, you want to retrieve the data of a trip the customer made, which was immediately before a given date. In other words, the last trip before that date. And suppose you want the information to be output in a list that prints the trip data. The procedure receives in a parameter the identifier of the customer who wants the information and the search date. In the source of the procedure, there's a for each that runs through the trip table, and the where will filter by the trip ID returned by the max formula. Next, the data corresponding to that trip will be printed. In the max formula, the attribute to maximize is trip date, since we want the trip that was immediately prior to a given date. So it'll be the trip with the highest possible date, but lower than or equal to the search date. The aggregation condition specifies that the trip must have a date lower than or equal to the given date, and also belong to the customer requesting the information. The default value returned if no trip is found that meets these conditions is 0, and in case it's found, it'll be the identifier of the trip found. Now let's analyze what we've programmed. The for each will iterate over the trip table and set that context for the max formula. The max formula will also iterate on the trip table, but due to the context, an automatic filter will be set because both tables are related. In this case, is the same table, so the formula will be filtered by the trip ID that's positioned in the for each. Therefore, it will always return the trip ID in which the for each is located, and will be like not having written anything. This is not what we need. In short, we need to be careful when an aggregate formula navigates the same table as that of its context, because most times, if we don't specify otherwise, it'll apply a filter by primary key, which will cause that the navigated table will not be navigated at all, and will always retrieve the same record in which it was positioned. The solution in this case is to first run the formula to look for the trip identifier that meets the desired conditions, and then filter the for each by that identifier value. Now let's look at a similar case to the previous one in a global formula, in which given an invoice from a customer, we want to find the date of the previous invoice from the same customer. To solve this, we'll use a max formula similar to the one we defined before, but defining an attribute as a global formula. Note that again, we're trying to define a formula that will navigate over the same table associated with the formula. So again, the formula will be filtered by its context and will only navigate over a single record. The difference between this case, which is a global formula, and the previous one, which was an inline formula, is that in the previous one, we could trigger the formula outside the context table to break the implicit filter. But in the case of a global formula, this is not possible, so we can never have a global aggregate formula that navigates the same table. For this purpose, we'll have to define it as a horizontal formula and perform the calculation within a procedure. In summary, this confirms what we said before, that although aggregate formulas don't need a context to be evaluated, as horizontal formulas do, in the event that such a context exists, not all the records that the formula explicitly establishes will be considered, but only those that also match the implicit conditions that arise from that context. And also, it's important to make sure that the context does not invalidate the objective we were looking for with the formula, as we saw in the last examples presented.